Hello friends of EduMath, this is Gerard Makumba, and in this video we are going to look at meeting and catch up of two moving objects. And if you are new here at EduMath, consider subscribing and hitting the notification bell. For now, let's get started with a guiding question. Alright, a particle moving in a straight line with the uniform acceleration a meters per second squared passes a certain point with velocity u meters per second. Now before we continue here, let us have a sketch. So we're going to assume this particle passes this point. This is the point they are talking about, with initial velocity u meters per second, and it is traveling at an acceleration of a meters per second. Alright, then they tell us that 3 seconds later another particle moving in the same straight line with a constant acceleration for over 3 meters per second passes the same point with initial velocity, this one. If we are passing this very point, so this is going to be the first particle. Now let me put down here the second particle. Passes through the same point with a velocity of 1 over 3 u meters per second, and for it is traveling at a higher acceleration 4 all over 3 meters per second squared. Okay, now let's talk about this phrase here, that 3 seconds later the second particle moving in the same straight line. This phrase here is going to bring in the time. So the first particle is moving within time t, so the second particle will be moving within time t minus 3, because it delayed for 3 seconds before it passed this point here. Right? The first particle is overtaken by the second when their velocities are 8.1 meters per second and 9.3 meters per second respectively. So at the point of overtake, it means that these particles will have traveled the same distance. At the point of overtake, the particles have traveled the same distance from this point here. Then they have also given us that the final velocities for these bodies, that is at the point of catching up or overtaking one another. At this point, the first particle has 8.1 meters per second, and the second particle has the final velocity there as 9.3 meters per second. Okay, find the values of a and u. They need us to find the value of a, which is the acceleration, and u, which is the initial velocity for this journey here. Now, since we know that we need to find u, we've been given the final velocity, we have the acceleration, we know that the distance that will be traveled by the two particles will be the same, so we are going to use v squared equal to u squared plus 2as. Okay, then we consider the first particle. We shall have its final velocity as 8.1 squared being equal to its initial velocity. It is u squared plus 2 times as. But we know that from this point where they passed to the point of overtake, both particles will have traveled the same distance. So here what we are going to do here is to make s the subject, such that at the end of the day we can equate. So making s the subject from here, s will be equal to 8.1 squared minus u squared all over 2a. Call this equation 1. Then we have to consider the second particle. Still in the same vein, we are going to use v squared being equal to u squared plus 2as. Alright? Okay, so the final velocity for the second particle is 9.3 meters per second. It is squared here being equal to the initial velocity of the second particle is 1 over 3 u and squared plus 2 times the acceleration of the second particle, which is now 4 over 3a, then times the distance traveled by the second particle. Can call it just s. Then we have to make s the subject here. Before we make s the subject, we can go ahead and simplify this. This is 86.49 being equal to 1 over 9 u squared plus 8 all over 3 a s. Okay, so we need to make s the subject. S will be equal to 86.49 minus 1 over 9 u squared all over 8 all over 3a. Let this be our equation 2. So now, since from this common point to the point of overtake, both particles move the same distance, we are going to equate equation 1 to equation 2, showing that the two distances are the same. Equation 1 can be simplified as this. Here is 65.61 minus u squared all over 2a. This should be equal to 86.49 minus 1 over 9 u squared all over 8 all over 3a. Okay, now we need to simplify this here. We can now cross multiply here. Shall have 8 all over 3a into bracket 65.61 minus u squared should be giving us 2a into bracket 86.49 minus 1 all over 9 u squared. So if we happen to divide both sides by a, we can see that a will be leaving our equation. So we shall remain with 8 all over 3 into bracket 65.61 minus u squared equal to 2 into bracket 86.49 minus 1 all over 9 u squared. The next thing is we are going to eliminate this fraction by multiplying 3 on both sides. So we shall have 8 into bracket 65.61 minus u squared, giving us, this is going to be 6, multiplying here by 3 into bracket 86.49 minus 1 all over 9 u squared. Okay, now the next step is to open the brackets here. So 8 times 65.61 gives us 524.88 minus 8u squared. This should be giving us 6 times 86.49 gives us 518.94 minus 6 all over 9 u squared. Okay, now collecting like terms, we shall have 524.88 minus 518.94 being equal to 8u squared minus 6 all over 9 u squared. This here gives us 5.94 being equal to, when we simplify this, we get 22 all over 3 u squared. When we multiply both sides by 3 and then we divide by 22, we shall have to get u squared being equal to a fraction which is 81 all over 100. We are interested in u, meaning we have to go ahead and take the square root on both sides. So we shall have u being equal to the square root of 81 all over 100. By indices, u is going to be equal to 9 all over 10 meters per second. That is our value of u. Now, since we do not know the distance between here, we do not know the value of t, but we know the final velocity and we now know the u. We can now go ahead and use the first equation. V is equal to u plus at, and considering the first particle, We know the final velocity for the first particle is 8.1 being equal to, now the initial velocity, that is u, for the first particle, 9 all over 10, which can be written as 0.9, plus, we do not know the acceleration and we do not know the time. Have this as 80. Call this equation 3. Now considering the second particle and using the very equation, second particle's final velocity is 9.3. Initial velocity of the second particle is a third u, and we have got the value of u. So this is a third of 0.9, plus the acceleration of the second particle was higher and it was 4 over 3 a. And now the time for the second particle delayed 3 seconds. So it's going to be t minus 3. Okay, so this is 9.3 being equal to, we work on this, this is 0.3 plus 4 all over 3 80, okay, minus 4a when you open the brackets here. You can call this equation 4. Now, putting equation 3 in equation 4 will give us the value of a. So from equation 3 we can make at the subject. This goes the other side. We have this is equal to 8.1 minus 0.9. So at is equal to 7.2. Then you are going to put this in here. Where there is 80, we shall put there 7.2. Then that will help us to find the value of a. So we have 9.3 minus 0.3. When this crosses, we shall remain with 9 on the left hand side, equal to, here it's now 4 over 3 times 7.2 minus 4a. This is 9 being equal to 9.6 minus 4a. When 9.6 crosses, negative 0.6 being equal to negative 4a, and the a is now equal to 0.15 meters per second squared. That's the value of a. Okay, so we are done finding the values of a and u. Okay, part B, distance traveled from the point they passed to the point of overtake, from here to here. So to find that distance, we are just going to make use of either equation 1 or equation 2. But I'm going to choose equation 1 and get the distance s. Because we have u, we have a. From equation 1, s is equal to 8.1 squared minus u squared over 2a. We have a, we have u, so can now be able to substitute well there. Displacement will be equal to 65.61 minus our u, we got it as 0.9 meters per second, and here it is squared all over 2 times 0.15. So when you simplify the numerator, displacement is equal to 64.8 divided by 0.3. Displacement now becomes 216 meters. There when we get our calculator. Now my dear viewer, I want to thank you very much for being part of EduMath. And at this point, I would like to leave you with one question that you need to pause the video to have it written down and you practice it on your own. So here we go, and that is our practice question. Now please, if you are new, consider subscribing and also recommending the channel to your best friends. In the case of any comments, please leave them in the comment section, and you can as well give this video a thumbs up if you have benefited. For now, from us EduMath, say God bless you and see you.